going to show you how to solve equations. An equation is nothing more than a balance scale, where the left side is equal to the right side. So if I have a typical balance scale here, on the left side I have 2 plus 2. On the right side I have 4. 2 plus 2 balances 4. There's the pivot point of the balance scale. That's the equal sign on an equation. So the basic concept of solving all equations is whatever you do to one side of the equation, you have to do the exact same thing to the other side of the equation so that the equation still balances. So we'll take, first of all, the key to solving equations is to maintain balance. Here's a couple typical addition equations that we'll solve. So first of all, let's take a look at the one here, x plus 5 is 9. The balance point is the equal sign right here. And we'll take, and this would be the stand that the equation that the balance scale stands on. So now I can do whatever I want to one side as long as I do the same thing to the other side. The concept of solving an equation is to isolate x. We want to know what x is, x the unknown. You can use any letter you feel like, but in this little presentation we have here, we're just going to use the letter x just to keep it all the same. So if I want to find what x, well, I already know what x is. I can look at that, and I can pretty much tell by trial and error that x is 4 because 4 plus 5 is 9. But that's guess and check. We want to know how to solve equations using mathematical steps. So to solve this equation, we need to get rid of that 5. So if I took, if this were balance scale, if I took and subtracted 5 from the left side, I'd have to subtract 5 from the right side. Negative 5 equals negative 5. Here's my line. I bring my equal sign right down. I always line up the equal signs. 5 minus 5, of course, cancels out as nothing. That's why I picked that, to get rid of it. And what I'm left with is x. And on the right side, 9 minus 5 is, well, 4. Now I've solved the equation rather than just guessed and checked at it. But I can check my work. If x is 4, 4 plus 5 is 9. Here's another typical addition equation. Addition equations are solved by subtracting. You always do the opposite operation. Somebody made that equation. They added 7 to x to get that number. You have to undo what they did. So we'll get rid of the 7. So I'm going to subtract 7 from the left side and 7 from the right side. So here on the left side, here's my balance scale. Here's the stand that my balance scale stands on. Try to line that up better. 7 minus 7 is nothing. I'm left with x. Bring down my equal sign. Negative 11 and negative 7 is negative 18. Now I can check my work. Negative 18 and positive 7 is indeed negative 11. So that's basically how we solve an addition equation, by subtracting. Now we'll solve subtraction equations. Well, to solve subtraction equations, we add. To get rid of subtraction, we add. We do the opposite operation. The opposite of subtraction is addition. So here's the stand that my balance scale is on. On the left side of the balance scale stands x minus 10. On the right side is an 11. They're balancing quite nicely. I want to get rid of that minus 10 because I don't want to know what x minus 10 is. I want to know what x is. So I'm going to get rid of that. How do I get rid of negative 10? I add positive 10 to both sides of the equation. And here we go. Negative 10 and positive 10 is nothing. I'm left with x. X plus nothing is x. 11 plus 10 is 21. Now I can check my work. If x is 21, 21 minus 10 is indeed 11. So here's another typical subtraction equation. X minus 7 equals negative 11. Here's the stand that of my balance scale. On the left side, I have x minus 7 balancing negative 11. I want to know what x is. I don't want to know what x minus 7 is. They already told me it's negative 11. I don't care. I want to know what x is. I have to get rid of the minus 7. The opposite of subtraction is addition. So I add 7 to both sides of my equation, maintaining my balance. 7 minus 7 is still nothing. I'm left with x. All I ever wanted was 1x over there. Negative 11 and positive 7 is negative 4. Now I can check my work. Negative 4. Negative 4 and negative 7 is indeed negative 11. But you see how I didn't do that by guess and check? I solved it. I did mathematical operations. I subtracted something from both sides of the equation, or I added something to both sides of the equation, and solved the equation. So that's basically how we solve addition-subtraction equations. Next we have multiplication equations. Now multiplication equations, it's the same concept. Here's the stand that my balance scale is on. On the left side of my balance scale I have 4x, on the right side I have 32. So this is 4 times x is 32. And I don't really want to know what 4 times x is, I want to know what 1 times x is. 1x, one lonely x. The opposite operation of multiplication is division. So I'm going to divide each side of this equation. I'm going to make a fraction. A fraction is a division problem. I'm going to divide each side by, well, 4, of course. It's 4 times x. I want to get rid of the 4. I'm going to divide each side by 4. Now, 4 divided by 4 is 1. Cancels out. I have 1x. All I ever wanted. Equals 32 divided by 4, which is 8. So I've solved the equation. Now I should check my work. If x is 8, 4 times 8, well, is indeed 32. Here's another typical multiplication equation. 7 times x is 84. Well, how do we do that? First of all, here's the stand that my balance scale is on. 7 times x is 84. I perform the opposite operation, which is division. I divide each side by 7. And again, 7 into 7 is 1. That's why I picked it. So I have 1x. All I ever wanted is 1x. 84 divided by 7 is, well, 12, of course. Now I check my work. If x is 12, 7 times 12 is indeed 84. Now, that's a typical multiplication equations. We solve every multiplication equation by doing the opposite operation, which is division. Next we have division equations. Now, division equations look a little deceptive sometimes. If you just look quickly at x divided by 4 is 8, many people would put down that x is equal to 2, but x is not equal to 2, because 2 over 4 is 1/2, not 8. That's not how you solve a division equation. You solve a division equation by doing its opposite operation, which is multiplication. Here's the stand that my balance scale is on. X divided by 4 is balancing 32. I don't want to know what x divided by 4 is. I want to know what 1x is. I have to get rid of the 4. To get rid of the 4, I perform the opposite operation. This is a division equation. I'm going to multiply each side by, well, the 4 to get rid of it. So there's 4 here, and multiply 4 here. Now, if you want, you can put a 1 under here, so it looks like, a fraction, a whole number, stick a 1 under it to hold it up. Now we're going to cancel that out. 4 into 4 is 1. And what do I have? 1x. Again, all I ever wanted was 1x. I don't want x divided by 4 or 4x or 50x. I want x. 1x. There it is. 8 times 4, well, 32. Now I can check my work. 32 divided by 4 equals 8. Don't be tempted to skip steps. Do the work. Show the steps. Get it right every single time. Here's another typical example of a division equation. X divided by 3 equals 6. Now again, many people be tempted to go 3 into 6 is 2. Well, 3 into 6 is 2, but that's not how we solve the problem. This is a division equation which we're going to solve by multiplication. We're going to get rid of that 3. Somebody came along and divided my x by 3. I'm going to multiply each side by 3, the opposite operation. Here we go. Now again, you can put a 1 under it if you want. The 3's cancel out. See you later, bye. Off we go. We have 1x, all we ever wanted. 6 times 3, 18. Check my work. 18 divided by 3 is indeed 6. So now, basically, that's all there is to multiplication and division equations. You solve multiplication equations by dividing. You solve division equations by multiplying. Now next, these are the basic 4 things, the add, subtract, multiply, divide equations, which you solve with opposite operations. The next kind of equation that we run into is a 2-step equation. Now, first of all, let's think about how to make a 2-step equation. So we start with the answer. We start with x is 4. I just arbitrarily picked x is 4. I just felt like it. Now, I'm going to do something to each side of the equation. I can do anything I want. So I think I'll take each side of this equation and I'll multiply it by 3. Now keep in mind again, here's the stand for your balance scale. Whatever I do to one side, I have to do to the other to make it balance perfectly. X times 3 is 3x. Bring down the equal sign. 4 times 3 is 12. Now I've actually made a multiplication equation. 3 times x equals 12. How would I solve it? I'd divide each side by 3, wouldn't I? Because I just multiplied by 3 to get there. To undo it, I'd divide by 3. Well, I don't want to do that yet. I have more to do. So I have 3x equals 12. I want to do something else to that equation just to make it slightly more complex. I'm going to subtract 2 from each side of the equation. So on the right side, I'm going to have 12 minus 2. On the left side, I'm going to have 3x minus 2. And what is 3x minus 2? Well, it's 10. What's x? I don't know, but I'm going to find it. Now, here's a typical 2-step equation. 3x minus 2 equals 10. Now, I just made that equation. The way we solve a typical 2-step equation is to undo what someone did to get there, to go backwards. So this is backwards reasoning. So what's the last thing I did to make that equation? Well, I subtracted 2 from each side, right? Well, what's the opposite of subtracting 2? Is adding 2. So I'm going to just change the color to make it look prettier. We'll add 2 to the left side. We'll add 2 to the right side. Keeping in mind again, this is the stand for my equation. So 10 plus 2 is 12. Bring down my equal sign. 2 minus 2 is nothing. See you later, bye. We're left with 3 times x. So here's the first thing that I got right here, the 3 times x. How did they get to 3 times x is 12? I multiplied each side by 3. I'm going to do the opposite operation. If I multiply by 3 to get there, I'm going to divide by 3 to come back from whence I came. So here, just change the color a little bit to make it easier to see. I'm going to divide each side by 3. Fraction is a division problem. 3 into 3 is 1. 1x. All I ever wanted is 12 divided by 3, which is 4. Well, I knew that, didn't I? I just made the equation. X is 4 up here. But if I'm just presented with this, this is how I solve it. How did they get that? This is how they made it. So the people writing the math book, they started out with something like this. They knew the answer ahead of time. They performed a couple of simple operations to make a somewhat more complex equation for you to solve. How do you solve it? You undo what they did. Just that simple. Then, let's see, we've got one more here. Now, to solve a 2-step equation, you see how I just made that up? I undid what I had done to solve it. In general, if you have a 2-step equation, like 3x plus 2 is 7, something like that, you have 2 operations in there, the basic rule to solve a 2-step equation is to get rid of the addition and subtraction first. So to get rid of the addition and subtraction first, let's take another typical 2-step equation. This one's already been made. We don't know what the answer was. We don't know how they started, but we're going to find out pretty quickly. If you have 2 times x plus 5 is 17, the rule I just said, get rid of the addition and subtraction first. Here's the stand. Now, why am I saying get rid of the addition subtraction first? Because that's the last thing that was done to make that equation. I know that. Now you know that. So what do I get rid of? I get rid of that 5. I don't want the 5. I want x. I don't care what 2x is equal to, and I don't care what 2x plus 5 is equal to. I want to know what x is equal to. I need to get rid of everything near that x. And the first thing I'm going to get rid of is the addition subtraction. Somebody came along and added 5 to my 2x, I'm going to do the opposite operation. I'm going to subtract 5 from each side of that equation. Here we go. Minus 5, minus 5. Off we go. 17 minus 5 is 12. Here's the equal sign. 5 minus 5, well, nothing, of course, equals, well, the 2x. So now we have a typical multiplication equation. 2 times x is 12. And how do we solve a typical multiplication equation? We divide. The opposite of multiplication is division. They multiplied my x by 2. I only want x, I don't want 2x. So I'm going to divide each side by 2. 2 into 2 is 1. I have 1x, all I ever wanted, the 1x. 12 divided by 2 is 6. So I'm pretty sure I've done that correctly because I subtracted 5 pretty well. I can divide by 2 pretty well. I should check my work, however, so we will. If x is 6, 2 times 6 is 12. 12 plus 5 is indeed 17. So we've solved the typical two-step equation. Now, here's another typical two-step equation. Just because it has a couple minus signs, negative signs in there, it doesn't change how we solve it. The basic rule, it's a two-step equation because you got negative 3 times x, so there's an operation, plus 4, there's another operation. So if it has two operations, it's going to take 2 steps to solve it. How did they make it? Well, you know what they did? The last thing they did to make that? You know what the last thing they did was? They added 4 to both sides. That's why the basic rule is to get rid of the addition and subtraction first. So I'm going to get rid of that 4. Now, here again, here's the stand to my balance scale. I'm going to get rid of that 4. I'm going to subtract 4 from the left side, 4 from the right side. And you can do it in either order. It makes no difference. Negative 5 and negative 4 is negative 9. 4 minus 4 is, well, nothing, of course. That's why I picked it, to get rid of it. What am I left with? Negative 3 times x. Now I have a typical multiplication equation. How do I solve a typical multiplication equation? I divide. I do the opposite operation. Let's take another column. So if I have negative 3 times x is negative 9, I'm going to divide each side by, well, the negative 3, because I want to know what x is. I don't want to know what negative 3x is. I don't want to know what negative 3x plus 4 is. Any of that. I want x. I have to get rid of everything else. So I'm going to get rid of that negative 3 because it's a multiplication. I'm going to divide each side by negative 3. Negative 3 divided by negative 3 is, well, positive 1, of course. 1x, all we ever wanted. Negative 9 divided by negative 3 is positive 3. Now, maybe we should check our work, just in case, because we've got a bunch of negative numbers running around the list. We'll see if we lost any along the way. If x is 3, negative 3 times 3 is negative 9. Negative 9 plus 4 is negative 5. So this is indeed the correct solution to a typical two-step equation. So now you know how to solve equations. So let's go right back quickly. An equation is nothing more than a big balance scale. 2 plus 2 equals 4. There's the pivot point. There's your balance point. There's the equal sign. Key to solving equations is to maintain balance. Here's a couple typical addition equations we solved. They added 5. We got rid of it by subtracting. They added 7. I get rid of it by subtracting. Here's a typical subtraction equation. They subtracted 10. We got rid of it by adding 10. They subtracted 7. We added 7. Just to solve the equation. Typical multiplication equations. They multiplied by 4. We did the opposite operation. We divided by 4. They multiplied by 7. We divided by 7. We also checked our work. Division equations, little bit tricky. Be careful on a division equation. You may look at it and think you know the answer. Check your work. Always check your work. X divided by, we multiplied by 4. I got rid of it. X was 32, not 2. Here, we got rid of the divide by 3 by multiplying by 3. X was 18, not some other number. Typical two-step, how to make a two-step equation. We just started with the answer, multiplied each side by something, subtracted something, and made a typical two-step equation here. 3x minus 2 equals 10. Then we solved it. We solved it by undoing what we did. The last thing we did was to subtract 2, we get rid of it. We add 2. The next thing, we multiplied by 3, we get rid of it. Opposite operation, we divide by 3. Here's our answer, x is 4. Then, let's move that up a little. Now, two-step equations, the basic rule that you should memorize from now until the end of the day of the earth is get rid of the addition-subtraction first. It will make the equation a lot easier to solve. And then we have a typical two-step equation. We got rid of the addition-subtraction first, then we divided by 2. It's a multiplication. We divided to solve it. We checked our work. And then, finally, one with some negative numbers. Looks like it might be difficult, but it's the same concept. Get rid of the addition-subtraction first. We got rid of the 4. See you later, bye. Negative 3x was negative 9. They multiplied by negative 3. We did the opposite. We divided by negative 3. We have the answer. No guessing and checking. No guessing and checking. We simply solved it using simple math, period. Checked our work. It's done. This is how we solve equations. Thank you very much, and happy computing. I hope that came out. 22 minutes.